Hi everyone! Today I'm going to introduce you to the growing concern of feminization in sea turtles. In this context, feminization refers to the growing imbalance of sex ratios with more female turtles hatching each year. Turtles are temperature-dependent sex determination species, or TSD for short. This means that the temperature directly influences the sex of their offspring. So the temperature eggs are exposed to during the middle third of embryo development will determine the offspring of that hatchling. Therefore, temperature is really important when taking a look at the sex ratios for turtle populations. For turtles specifically, we see that the pivotal temperature falls at about 29 degrees Celsius. This is the point at which you would see a 50-50 split of female and male turtles in a nest. At 31 degrees Celsius and above, you would see an all-female clutch, and at 27 degrees Celsius and below, you would see an all-male clutch. Anything in between there falls in the transitional range of temperature, which is where you would still get a mix of female and male turtles, just not that nice 50-50 split you see at the pivotal temperature. This is a growing area of concern, especially in current years, because of climate change and global warming. We're seeing temperatures rise at a rapid rate, and therefore there needs to be a rapid increase in this area of study because temperature is so influential in the sex ratios for turtle populations. Fortunately, there are groups of researchers who are looking into feminization in our turtle populations. Here are two highlighted studies, the first of which is looking at hawksbill and green turtles in the Red Sea region. The second group of researchers is looking at hawksbill turtles in the Yucatan Peninsula. You can see the lead authors for each of these studies on the left. In both cases, the main purpose was to determine temperatures at different sites and determine the sex ratios for these nest sites. To take a closer look at our first study, just as a reminder, this was in the Red Sea region, looking at our green turtles and our hawksbill turtles. The two variables of interest were depth and site location. The authors believed that these would influence temperature and, by extension, sex ratios. They calculated sex ratios using a mathematical model, and they looked at pivotal temperature, which, as a reminder, is the point at which you would see a 50-50 split of female and male turtles in a nest, as well as the thermal threshold, which is the point at which you would start to see effects to the embryo, which could eventually lead to turtle mortality. The key purpose here was to determine which sites we were going to experience high levels of feminization, as well as to see which sites exceeded the thermal threshold. Our authors took a look at 5 different sites that were selected based off of the nesting evidence they saw there. They recorded sand temperature from May to September every 15 minutes, with temperature loggers buried at 30 and 50 centimeter depths. You can see the temperature logger is that small green device all the way to the right. They recorded the daily mean and max temperature and calculated the percent of days above the max threshold. And like I mentioned, they used a mathematical model to predict sex ratios for each of these 5 sites. If you take a look at our first set of results here, this is looking at sand temperature. Each of the colors correlate with a site location. A solid line is for 30 centimeters, and a dashed line is for a depth of 50 centimeters. You can see the pivotal temperature is that bold black line at the lower third of our graph. And you probably will notice that the majority of temperatures are significantly above our pivotal temp. You might also notice that the sand temperature is slightly cooler at 50 centimeters compared to 30, as well as being slightly cooler earlier in the season and on average warming up as the season continues. Here is our data for the max thermal threshold results. The max thermal threshold was defined at 33 degrees Celsius, and you can see that all of our sites, except for our northernmost site, exceeded the thermal temperature. Unfortunately, we're seeing that at least 50% of the days for the majority of our sites is exceeding that thermal threshold, and so we would expect to see higher rates of turtle mortality at those sites. You may also notice that the sand at 30 centimeter depths exceeded the threshold more often, just because it is closer to the surface where the sun is beating down on the sand. Here is our sex ratio predictions. The set of data is for our hawksbill turtles, which have a nest depth at 30 centimeters. You can see the model that was used to make these predictions down at the bottom of our figure. And you'll probably notice that we're seeing highly skewed sex ratios again in all of our sites except for the northernmost site. But even there, we're reaching upwards of 75% female turtles at the height of the nesting season. Here's our data for our green turtles with an average nest depth of 50 centimeters. This data is quite similar. However, you'll notice that the percent female is slightly lower just because sand temperatures are a bit cooler at 50 centimeters compared to 30 centimeters. However, we're still seeing highly skewed sex ratios, upwards of 100% for the majority of our sites here. Our key conclusions are that the Red Sea region sand temperatures are exceeding the pivotal temperature and are consistently reaching our max thermal tolerance. This means that our sex ratio predictions are going to be skewed highly female, and the authors also suggest that we might see higher levels of turtle mortality at many of these sites. I did just want to mention that the recorded sand temperatures here were amongst the hottest in the world, so I know this data is quite alarming, but at least at the moment, to some extent, this is the worst case scenario. Moving on to our second study at the Yucatan Peninsula, looking at hawksbill turtles. The authors here believe that shade and human impact would influence temperature and, by extension, sex ratios. They also looked at the pivotal temperature, and they calculated sex ratios using the gonads of dead hatchlings to confirm the predictions that were made using a mathematical model. Again, the purpose was to determine sites with high levels of feminization. These authors also wanted to determine the impact of shade and human impact on our nesting sites. So these authors looked at 3 different beaches, each with different anthropogenic and littoral characteristics. Most notably is the amount of vegetation at each of these sites. You can see at our first site down at the bottom that there is plenty of vegetation compared to our third site, which is really lacking in greenery and is also right by a road. They recorded sand temperature from June to September, and the loggers were put directly into nests and recorded temperature every 30 minutes. Like I mentioned, they did sex the dead hatchlings to make sure that their estimates for sex ratios were in fact accurate. If you look at our temperature results, you can see each of the 3 beaches are color-coded, and you can see each of the sites at each beach. Again, our pivotal temperature is at the lower third of that top graph, is that dashed black line at about 29 degrees Celsius. Most importantly, we see that the beach that had the least amount of vegetation has the highest temperatures on average. If we take a look at the figure on the lower half of our slide here, you can see that the incubation temperature was warmer than the pivotal temperature by 1.25 degrees Celsius in 82% of the female-only nests. So this is really important because most literature was citing at 31 degrees Celsius, you would see an all-female clutch, but this data is suggesting that it actually might be closer to 30 degrees Celsius instead. If you take a look at the sex ratio results, again, this is quite concerning data. We're seeing high levels of feminization across our beaches, especially from August through September, where it's reaching 100% females at all but one of our sites. Additionally, our third site here had the greatest level of feminization, and it only had 0.5% of the nests shaded. So the beach that had the least amount of vegetation has the highest temperatures and, as you could probably predict, the greatest level of feminization. So our key conclusions here are, again, sex ratio predictions are skewed highly female. In this case, the feminization trend is due to a low percent of shade, which is attributed to coastal dune deforestation, as well as climate change. The authors believe that the percent of shade above nests was the main factor that helped to decrease temperatures, and therefore they suggested that conservation efforts prioritize vegetation, as well as reforestation programs on these beaches. If we take a look at our overarching conclusions, we see that feminization is occurring in multiple areas. We see it in the Red Sea region, we see it at the Yucatan Peninsula, and we see it at the majority of other sites that are being studied around the world. We're seeing upwards of 90 to 98% female turtles at the majority of sites worldwide, which is very concerning. For these 2 sites, we saw that temperatures were often above the pivotal temperature and above 31 degrees Celsius, so we would see most of our nest sites having all female clutches. We also saw that temperatures sometimes exceeded 33 degrees Celsius as well, which means we're not only going to see high rates of feminization, but potentially higher rates of mortality too. Lastly, we saw that nest depth and shade were key factors in helping to control temperatures at these nesting sites. So why is this all important again? Well, these studies in particular were really critical because there hadn't been prior research about pivotal temperatures for these specific areas. We saw in our second study that it might actually be that the cutoff point for an all-female clutch is closer to 30 degrees Celsius instead of 31 degrees Celsius, as much of the literature cites. We also know that these sites in particular are really important to our turtle populations. The Red Sea is home to 5 of the 7 current species of turtles, and the Yucatan Peninsula is home to the largest nesting population in the Atlantic. Lastly, in order to have effective conservation efforts, we need data on what factors are influencing temperature. For example, the data from our second study suggests that shade is a key factor in curbing temperature, and therefore helps to support efforts to reforest beaches and even legislation banning deforestation. Without this type of data and data from studies across the globe, we will be unable to direct meaningful conservation to areas that need it the most. This is why continued study of these areas, as well as on beaches worldwide, is paramount in saving turtle populations in a warming world. Thank you.